Okay, so the test, or this chapter, covers three main things. Number one, first thing we did was how to do linear regressions by hand, without a calculator, without a spreadsheet. And I'm actually going to use the data from today, attempt number 3, if I can find it. Watch this. I know where to get it from, though, right here. So we had 417, 612, 82, and 101. Okay. I didn't leave off that one on purpose, actually. It deleted it, and I felt too lazy to go fix it. So I'm like, four data points. That'll make it easier for them. So these are the actual y values, and our predicted y values come from this equation. So -3, basically we're going to plug in all these x values into this equation. -3 times 4 is -12 plus 30, which is 18, I believe. -3 times 6 is -18 plus 30, which is 12. And now I'm going to do 8. -3 times 8 is -24 plus 30 is 6. And lastly, -3 times 10 is -30 plus 30, which is 0. Okay. And then the next thing is, these are called our regressions. That's when you take the actual y value and subtract the predicted y value. So 17 minus 18, 12 minus 12, 2 minus 6, 1 minus 0. Okay, and then we're going to square these. So it's these numbers squared. 1, 0, 16, 1. And then the average y bar, that's how you say it. It's just the average of the y values. I don't know. 17 plus 12 plus 2 plus 1 is 9, 10, 11, 12. 32. 32 divided by 4 data points equals 8. 8, 8, 8. Okay. Then, the deviations. That's when you take the y value and subtract the average y value. So these are called the residuals. These are called the deviations. So y minus average y value. 17 minus 8, 9. 12 minus 8, 4. 2 minus 8, -6. 1 minus 8, -7. Now we have to square these numbers. So it's y minus y bar squared. That's 81, 16, 36, 49. Okay. And then I'm out of room, but normally over here you would have some of the squares of the residuals and some of the squares of the deviations, but it's actually a blessing in disguise because I'm going to write it right there. So these are the residuals, the square of the residuals. I'm about to find the sum of the squares of the residuals. It's a mouthful, I know. 18. And I'm about to find the sum of the squares of the deviations. Okay, apparently I'm going to use a calculator. 81 plus 16 plus 36 plus 49 equals 182. Okay, and then r squared is equal to the sum of the squares of the deviations minus the sum of the squares of the residuals divided by the sum of the squares of the deviations. So we got 182 minus 18 over 182. I am feeling super lazy right now. 164 over 182. That is r squared. Like if you didn't have a calculator, in the past when we were giving this test to the students, they had no choice but to leave their answer like that. Because it literally was no calculator. Had to do it by hand. So you would leave it like that, and then r would just be the square root of that. You would just put yeah. But you guys get to use calculators. So by the way, r squared, the actual technical term for that number that we're about to get, is called the coefficient of determination. Yes, you have to know these terms, but hopefully you wrote them all down a couple weeks ago when we first did this lesson. 164 divided by 182 is probably like at least 0.9. Dang. How did I guess so correctly? I'm going to go bam. And all you got to do is take the square root of that. I did notice on the assignment that people were writing things incorrectly, so it's just the square root of that. Clear square root of my guess is 9.95. Oh, dang. How do I get so lucky sometimes? 0.95. That is an extremely high R value. By the way, the technical term for R value is, oh my goodness, correlation coefficient. Makes sense, correlation, because we're trying to find if there is a correlation. And if you're doing research and you get that as your correlation coefficient, you would say there is an extremely high correlation between X and Y, whatever those two variables happen to be in real life. Okay, so that's lesson 1. You got to be able to do that in under 10 minutes. If you take longer than 10 minutes, you're literally just shooting yourself in the foot. The problem is, the only way to get good at this is by practicing it many times. Some of you ain't practiced it one time yet. I don't know what to do for you. But don't know what to do for you. Can't make you do your work, right? I can't make you try.